So today we're actually going to play with real lab gear. And I say that actually this is the kind that I made, so we're going to rename it. We're going to call it ghetto gear. Okay? So everybody gets a packet of my newly patented ghetto gear.
But do it in the. How'd you even do that? It fell in between the cracks.
Come on, Joey. So the ghetto gear. If we look at the lab gear, everybody open up your packet. Everybody open up your packet and look at what you have. So I want you to clear out a space on one of the desks or two of the desks. Clear out a space on two of the desks or one of the desks so you have enough room. And collect all of the gear, collect all the lab gear together and take an inventory of what you have. So set aside 1x squared and 8x's. Yes. Now you're gonna need one of you is gonna have to be a scribe. So you'll need a notebook, a blank notebook or a blank piece of scratch paper. Here's the challenge. Using only the 1x squared that you have and the 8x's, put everything else away. You can use as many ones as possible. There's no limit on the amount of ones you can use, except for how many you have. But you need to make as many rectangles as you can using the 1x squared and the 8x's and any other combination of ones. That's the one rule. You have to use every one of those 8x's and the x squared. So once you've made a rectangle, the scribe needs to draw that and write the equation for that rectangle. What's the length of this right here? No, what's the length right here? 4x. Well, of this x right here, this side length is x. Right? So what's the side length here? 1, 2, 3, 4, 5, right? So do we know what the side length of this big square is? It's an x, right? So this side length, we can't just, even though they may fit, you see how we can combine that? You need to match up the sides with one plus x times x plus 1, 2, 3, right? 4, 5. So what's another way you could arrange that? No! I'm switching. Okay. But yeah. You just have to use all of the 8x's.
And not all the ones. But it has to be able to be multiplied like together. So we can't have like this and then have like ones on top or ones on top. Because then it's like, how are we going to multiply 4 times into this x? Right? It would mean that the x value is actually. Hence, we have to do it like using. Do we have to use all of them? Yeah. Like every time? Every time.
So, which other ones?
How about no? Let's make one doing this.
Just right here.
Then you know the value of x.
This work.
The value of x will be 1, 2, 3, 4, 5, and then this will be value of x. The whole thing.
We
could go long ways and add those on, just going that way.
Yeah, but there might not be space on the desk. No, never mind.
Yeah, I want
We have to make it area like
As long as
this.
we have enough ones that are the same length as well.
Setting them up, it looks like about 4 of the ones can fit into an x.
Here, let's
So if
test
we just add those all in,
Unless, you know,
because like
have
that,
the 2 intention.
because that'll maximize.
So,
But if you use it all, wouldn't it be the same size?
That's a X. That one's
Is that one?
so it's X plus what? The equation. You know how we've been doing the rectangles? This is an X. These are plus that. It's like the equation. Okay, so
Am I supposed to draw? Well, maybe.
No, this has to be an x. It's like
Yeah, well, it's an x times
x times
times 1. And those are technically times 1 even. Because if there's
right here.
You need to match up the sides.
well, no, well, it's x times x plus 1, 2, 3, 4,
I wonder
5,
if I can
6.
do this. Just put.
What's another way you can arrange that?
Where's the short stubby one? No. That short stubby one. I'm switching it because this one's like too long.
Well, it's still technically x.
Then we can put because these are all
Oh,
ones.
okay.
We just,
Gotcha.
but then we can do this again and make more of the ones.
What's that, Nicole? So now it's a full rectangle, right? What are the side lengths of this rectangle?
Put them all on one side.
Oh yeah.
X plus 7. So this is, do you have this one already? So when you, as you draw now, write out their side lengths.
In your combinations that you have so far,
Yeah, like using pieces.
or just that you've drawn right here.
Can you explain? Okay, so basically, we took this is one side length and this is another side length, and we're finding like the area of them. So we distributed it to find this, which is the area. So yeah, that's basically what it is.
These drawings, the darker line shows side lengths, the inside shows the area.
Okay, so on this one, we took x squared and we surrounded it with different x's and added the ones to fill the empty space, and then we just calculated what the side lengths were. We kind of did that for the rest of them too. So, and then we counted what we used and totaled it there.
No matter what, had to equal to 8 x's, and so that was just kind of like where we went with it, and we just like went down the row on this one, do 8, yes, and then we went all the numbers on that side too. Then we just like factored it, or not factored, distributed it. Yeah.
So were those all the rectangles that you were able to find? Did anybody find any rectangles that were different? You guys found a bunch of other ones. Which other rectangles did you guys find?
No, we just repeated them.
Or like this one, these ones are just they're technically different than those, but they're just like flip-flopped.
Does it matter, like in these cases? Does everybody see what we're talking about? We have an x plus 2 and then an x plus 6. Is that any different than an x plus 6 and an x plus 2?
No.
How does y intercept show in Is it the number of ones? Oh my gosh, it is! You are so smart.
And then the x-intercepts. So
X-intercepts are the side lengths. Just opposite.
yeah, they're the side lengths.
Opposite of side lengths or just the side lengths?
Opposite.
Okay. Opposites of the side.
Well, reciprocals.
Yeah, reciprocal. No, reciprocal would be
Times like -1.
Okay.
So opposite.
yeah, opposite.
So, and we can use these other boxes down here on the bottom. Yeah. So first of all, why are these ones misshaped? Why are they not rectangles?
Because the amount of boxes, like 12, is due to the y-intercept and the boxes, the other ones. Were
Are they the same box? Are they the same as the rectangles above?
Yes. Well, the amount of the y-intercept.
What's the same?
Yeah.
Area.
The areas that are the same, right? These ones are shaped as not as rectangles, right? These are just shaped as other
It's
polygons or whatever, L's.
all ours.
Let's just call them incomplete squares, right? These are incomplete squares. Well, what did we do to go from a rectangle to an incomplete square?
Oh, the X.
You took away the little square.
Yeah.
Multiply
We,
X.
Don't even try.
Go ahead, Peyton.
restate it real quick.
What did we do to go from the rectangle to the incomplete square in this case?
We took the average of the x's and plugged in the area of
We took the average of the x's and where did we put them?
on the sides.
On the sides. So now, where does my axis of symmetry show up in the lab here? Do you see this? I have 4 x's right here, right?
Yeah.
But I've already taken the average. If we're thinking of as negative b over 2a, I've already taken the average of them. So I just need the opposite of the side lengths, right?
So then with the negative 2a, you have the negative 4, and then missing the boxes you have, like, that's not,
Yeah, that one works.
yeah. Take the negative, not the negative.
So where does the y-coordinate? First of all, where do we get the y-coordinate after we find our x-coordinate of the vertex? What do we have to do before? We plug that value back in the equation, right?
Yeah.
Where do you see the y-coordinate, Peyton?
The y?
Yeah.
The y for the vertex or the y?
The y for the vertex.
The vertex, and we're missing the boxes. Where